All right, let me tell you about the presentation that we are going to have. Our next presentation is all about revolutionizing food testing through advanced analytical innovations. And I'm going to request Dr. Mukesh Sonawane, AGM Application Support, IndiFOSS Analytical, to please join me on the stage. Can we have a huge round of applause, everyone, for our speaker, for our presenter, who is going to present the presentation, which is very insightful and meaningful.
Good afternoon, everyone. I know it's time, but I will try to finish on the what time it has been designed. So basically, the topic for my discussion is like revolutionizing the food testing through advanced analytical solutions. Now, when we say about the revolutions, the revolution can be in terms of having the technology, identifying the exact gap which needs to be fulfilled between the what is market needed, what is the exact challenges, and what needs to be developed. So it may be in terms of either time, it may be in terms of maybe speed, it may be in terms of hardware, or it may be in terms of software. So we started discussion with maybe labeling quality, or maybe having the exact nutritional factors on the what we are mentioning on the food packaging. But if we have to talk about the overall food safety, it has a major impact on different parameters to be analyzed. So if we talk about the food safety market, it's obviously a huge market, which almost like 33,000 billions in Indian rupees, which is expected to grow with a CAGR of 7.7, and dairy is also one of the major parameters to be identified. Now, as we know that India is the largest milk producer, I will say the number one in the producing the milk in India. But if we thought overall export, in spite of having the number one in productions, we hardly export like 1 or 2% of milk. So obviously there is a gap. Obviously our intake is also, internal consumption in India is also very huge. But at the same time, there is also a gap in terms of food and dairy industry that needs to be fulfilled in terms of quality management. So when we talk about the food safety, so I personally can categorize food safety can be monitored at 3 different levels. One is the where the actually the source is. So source may be the in terms of where we are actually collecting the raw material. And there are chances that adulterations happen in the source level. So that adulteration can be either intentionally, which may be, say, for example, adding urea or sucrose into the milk to get the high SNF values. Then it may be like unintentional adulteration. This may come through the mycotoxins. And then maybe we can also call it as the incorrect nutritional values as a kind of a food fraud or need to be given attention. Then there are some of the challenges in process to maintain the food safety. Say, for example, maintaining the allergens, contaminations. And then in terms of storage, like having the mycotoxin, I will say the fungal infection, or maybe kind of, I will say the aflatoxin into the our storage conditions, that overall need to contribute the food safety. Now, this was the market challenge, but at the same time, food industry has their own different challenges like regulatory harmonizations. Because say, if I take the example of seafood industry, every country has their own or limited, I will say the regulations that need to be maintained by the manufacturer or who is exporting. Then another one is the quality improvement. Obviously, that's a challenge. But for that also, we need some technologies that need to have the adoptions. Then protecting the authenticity, like having a GMO or maintaining the what we are, like say, for example, if it is a basmati rice, how to verify this is a basmati rice. So that's actually, we called it as a protecting the authenticity. And again, the cost is one of the major factor when we are talking about the cost management. Now, though we are working on a different technologies, which includes like FTIR, NIR, flow cytometry, in some technologies for the pathogen testing, gas chromatography for the like ghee adulterations. So, but today's presentation, I'm going to focus on the food safety, which is basically in terms of 4 major technologies. One is the FTIR technology, then second one is the ELISA, then chemical analysis and the pathogen testing. Now, these are the testings which commonly happens in dairy and food industry. These are very common testing, but and it is not like that FTR is recently innovated. FTR technology people are using for like a decades for the different field, and there is hardly any field which does not use the FTR. It's like pharmaceutical, it's petroleum, it's chemical. FTR has been used for decades, and even like for last decade, even dairy and food industry is also using FTR and NIR technologies. Now, how FTR actually works, that's like that's not maybe for the today's topic, but we know that FTR is a kind of a technology which actually check the chemical structure of the any chemicals which we are looking for. And now, as recent advancement, AI tools or there are chemometrics method has been established, which actually identify whether the product which we are looking for is accurate or not accurate, whether what spectrum it should give, whether it is giving the same or it's different. So each chemical structure, like say for example fat, protein, we know where that peak should be, and if there is something new, then the instrument has a capability. Now, just before my presentation, someone talk about the adulterations. The sir mentioned about the culprits or the people who want to do the adulterations. They are even more smarter than actually the who is collecting the material and who is actually taking product into the productions. Now, what can be helpful, I will say kind of a revolutions or maybe advancement in terms of, say for example, the same instrument which is used for like a fat SNA protein, it's obviously the payment system is based on that, say for example. Now the same instrument which is detecting the 5 adulterations, so if there are like water, urea, sucrose, maltodextrin or ammonium sulfate, these are the adulterations, they are into the milk samples, so that need to be checked. Now, as we talked earlier, because those who want to do the adulteration don't want to get the financial benefit, they know that this instrument can detect these 5 adulterations. So he will try to have 6th adulterations or maybe 7th or maybe something. So the same spectroscopy without increasing the analysis time now can be converted into the different adulterations. Now we have a group of like 5 different adulterations. So now as a supplier, or if someone, there is a middleman who is trying to do the adulterations, he doesn't know what instrument is checking today. It may be like group A, group B, group C, that can be changed anytime on the site. So there is no, I will say the confirmation that which adulterations you want to add today. So this is how one can check the adulterations. Now, in terms of revolution, in terms of having like a yogurt analysis, fermented product analysis, ice cream analysis, the hardware can be improved from the a small, which is village level instrument, to a plant level instrument, which can analyze like milk, cream, whey, ice cream mix, chocolate milk, and multiple adulteration, maybe in just 30 seconds. So because of the having 30 seconds analysis time, one can have like hundreds or 200s or 500 sample each day. Now it's actually the post point, like how we can maintain the food safety, and source is the one of the major point where we can maintain the safety. The second technology is ELISA. ELISA is again like decades people are using ELISA. I will not say decade, it's like 2 decades or 3 decades. ELISA has been very commonly used in the like bio industry, pharmaceutical industry. In food safety also, ELISA becomes very important in recent days when we started checking the like antibiotics in milk, we started checking antibiotics in the seafood analysis, which started checking the mycotoxin. So one of the major in terms of food safety is like maintaining the mycotoxin in the raw material. Raw material can be our wheat, maybe corn, or maybe any material which has been used for the final product. And there are different mycotoxin because of fungal fungus into the aspergillus fungus majorly, that aflatoxin B1, DON, JD, so these are different mycotoxins that are present. Now, there are technologies available which can check this mycotoxins. But obviously now these are the technologies, like say for LCMS, MS, there is HPLC. Now these are the very specific instrument that needs some space, obviously, some temperature or environmental conditions, say for example air conditioning. So it is not possible to take such type of technologies onto the field. On the contrary, the rapid testing kits which having the like say for example same detection level at a very low level like ppb level detections, but now they are very easy to handle. So one can just need to take some samples, then do the rapid testing kit, something like our strip testing, and within like maybe in 5 to 10 minutes we can come to know that whether this raw material is easy to take or not, whether we can do something like that. So if I have say for example as an atom manufacturer, I can have the capability, I can check the wheat quality at its source level. Now is ELISA checking on the field is possible? Maybe with some electric connections, yes, there is like kits directly available We can take these boxes onto the field. We might need some electricity plug to just run the small instrument or reader, but it is totally portable, which we can take onto the field and we can check any type of mycotoxin onto the field itself. Similarly, the same technology can also use for the allergens, because now allergen testing is also important in food, so we need to maintain the allergens in terms of milk, in terms of egg, in terms of almonds, nuts. So there are multiple allergens has been already mentioned. So to check that quality, we need to have like a technology which can easy to handle, and we can have rapid analysis on that. So even at a PPB levels, such rapid testing can be helpful, where we just need to take the samples, we have to put a dipstick, and within like 5 to 10 minutes, you will come to know that whether allergen is present or not. So these are the kind of revolutions which can help manufacturer to work at a source level, which is one of the major part for the, I will say, in terms of maintaining the product quality. Because the reason is that when we have product manufacturers and we check the like a mycotoxin or we check on the protein, there is no go back to modify that one. Because so the best thing what we can do it, we can do the product quality maintenance at the even at the starting level or maybe at a processing stage. But whatever changes we want to do, we should do it like just before the having the processing done. Another like when we talk about the like what we talked about like is the unintentional adulteration. Like mycotoxin is the one thing. Nobody is interested to add mycotoxin manually. There is no financial benefit out of it. So it's kind of unintentional adulteration. But apart from that, there are intentional adulterations. There are nutritional level failing. So if, as a manufacturer, if someone has to give the 15% protein, how we can be sure that that 15% is really 15? Or even as a, if I am a manufacturer, how I can be sure that what I am labeling is accurate or not? So for that, there may be process variations, there may be temperature variations during the processing, or there may be some gaps where it is not easy to check the like each and every batch of the products due to time limitations. Say for example, if I take any product, say example as a butter as a product, where fat, maybe salt is one of the major factor and moisture is one. So in cheese, it may be protein important. So for fat analysis, we need like 4 to 5 hours. For protein, if we have to go by Geldal method, it takes around 2 to 3 hours. If I have to do the ash content, it takes like 4 to 5 hours. Now, if I have to, for one product, if I have to do 5 tests, it almost takes like 10 hours or maybe 12 hours. But there are technologies like, we call it as a secondary technology, which has built on the like primary technology. So kind of NIR instrument, we can consider it as a secondary technology, which can give like this fat, protein, salt, TS, or maybe ash in just 20 seconds or 30 seconds. So now whether these technologies can be adaptable, yes, the advantage is that even your process is going on, like every 1 hour we can bring the samples and we can check, or even 30 minutes we can bring the samples and we can check, so that we can monitor whether that process is actually going correct or not. That was about the NI technology, where the number of samples are very high. But there are also challenges in accepting the secondary technologies. Then primary technology is the most important. Like if I am a manufacturer, I want to go with the reference chemistry only, or I want to analyze protein through Geldal method only. So can Geldal method be automated? Yes, absolutely. Geldal can be automated with the type of instrument where if we do the digestion separately, then the distillation, the titrations, the calculations, everything can be automated. Now, how fast it will be? It can done analysis maybe in like 1 hour of digestion and maybe 10 minutes more. Simultaneously, the same Geldal method, which is normally a reference chemistry, within like we can have the auto sampler where 60 samples can be put at a time. Instrument automatically take the samples, you do the distillations, then the titrations, and all data can be connected with your SAP system, where protein analysis can be done automatically. Maybe the 60 samples in 4 or 5 hours can be done. So that's how the revolutions can bring in terms of accuracy as well as the time. And the last maybe topic to discuss is the pathogen testing. Now, pathogen testing or a total bacteria count is almost every field needs these testings, whether it's like a biological, it's pharmaceutical, maybe it's a food, it's dairy. Everyone needs pathogen testing because it is important in terms of health. There are regulatory guidelines which need to be maintained. Now, when we talk about the pathogen testing, by a traditional method, that is maybe we can consider like ISO 4288, that is I think a plate count method, where actually 72 hours are required to get the plate count result. Now there are two different ways to identify the pathogen or a microbial count. Is one is the either we go with the like a regular CFU method, or second is the MPN method, that is the most probable number. So these are most common methods. Now in plate count method, we do the like a normal serial dilutions. We plate it on the and we keep it like 72 hours, and after 72 hours we take the plates, we count maybe manually or maybe some colony counting. In the similar format, in NPN is the another method where we make a 3 different dilutions, put a 16 numbers of tube for the each dilution, almost 48 tubes. Then we keep it for some incubation time, and after that we check like which tubes has a turbidity, and based on that we calculate what is the number of CFU into that product. So can it be automated? So yes, there is a product called as a like a tempo reader and tempo filler, which actually is a miniature version, or I will say the faster version of our traditional MPN method, where already the ready-to-use cassettes are there. The similar format in normally in pathogen testing, we do the like a 1:10, 1:100, 1:1000 dilution. Instead of that, when we fill these cassettes, there are already like a 3 different segments based on the volume. So maybe like say, if I take example like 100 microliter, 10 microliter, 1 microliter. So we can consider it as a volumetric 1:10 dilutions and 16 tubes. Now we can check, the reader will check automatically, because if there is a bacterial growth, obviously there will be fluorescence emittance, and that fluorescence will be measured to identify whether the test is positive or negative. It will count automatically for which dilution, how many are the positive, how many are the negative, and based on that number, it automatically calculates what is the CFU per ml. That's one of the advantage of this method. So it's fully automated. We just need to have a pre-incubation if we are talking of very small concentrations. But if it is like a regular concentrations, like instead of having like 72 hours of test, we can have it in the next day as well. So we are moving from 72 hours to 24 hours. So that's one of the biggest advantage these technologies bring into the manufacturer side. The reason why this test become important, say for example, in some cases, like if I talk about milk samples, so for example, UST Tetra Pak, if you have heard about, normally if someone has to check Tetra Pak milk for its microbial quality, so first, because it's already high temperature treated, there is very small percentage of UST is there. So they have to keep this for the 5 days to grow a pre-incubation, and then maybe 72 hours in the test. So it's almost 8 to 10 days that samples is been in store. So that's we can reduce it to like a 3 days or 4 days. So it's a huge time gap. We can save it through these methods. Again, as I mentioned that it is not always a revolution. It is always not about having the new technology. It can be, again, we can have the same technology in a more advanced fashions without changing its basic chemistry. So for example, when I talk about the protein analysis, there is a technology, NI technology, which is a secondary technology. But if someone wants to go with the GelDAL, there are GelDAL automations are available. Similarly, for microbiology, if we have to go with the automations, there are automations are available. But if someone wants to go with the plate count method also, so there are also advancements available. Say, for example, when I have to do the plate count method, there is like I have to prepare the agar plate, then I have to sterilize that. So I have to prepare agar mix, then sterilize, and then pour into the plate, and then let it solidify. So this is time taking. Again, sterilization, if someone manually made some mistakes, so there are chances of contamination. Instead of that, based on the cold gel technology, there are ready-to-use plates available where we just need to put the 1 ml of our sample, which whatever dilutions we are working on, and that dilutions we have now the strips are so small. In a same oven where you are keeping the plate, we can keep like 100, 200 or 500 strips without any problem. So it is a kind of miniature version based on the like a gel, which we call as a cold gel technology, where the required nutrient is already been put onto the plates. One just need to open the plates and put the samples directly. There is no preparation of agar, no sterilization required. It is ready to use. And if we have to talk about the results, it's the same. Maybe I can show. So these are some of the example or plates. So it's the same way we are checking the like plate count. We are checking the actually manually counting like how the colony looks like. In a traditional way, we check on the like a glass plate. In cold gel technology, it's like on a, like a membrane where it's like, I will say it's like a, just like a polish plastic type of material, a square, where we just need to check the manually. We can also use the like we can say counting machines if as well. So it's totally a version of plate count which is converted into the rapid cold gel method. So in conclusion, yes, I can say, yeah, just I'm on conclusion side. So basically, when we talk about the food safety, as I mentioned, food safety need to be monitored not when product is actually manufactured. It should be monitored before it get manufactured, maybe at source level, maybe at the processing level. Now, when if we have to check that at source level and processing level, obviously there must be a technology which works at the source. It should work on the like village level where we are actually collecting the grains. It should work on the plant where it is going processing, not at the quality control lab, which is the final step. So to test at that position, we need to have technology which is fast enough. I can take without any electricity, maybe I can take without any sophisticated instrument, and I should have capability to analyze large number of samples. So even for one farmer, we should have capability to check one sample. So that's how if number of testings are high, obviously food safety is high. And to maintain that food safety or number of testing, we need to have some revolutionary methods in terms of speed, in terms of time. Thank you very much. Yes, thank you. Yeah, thank you. Yes, thank you.
Check. Thank you very much, sir. Sir, may I request you to kindly stay back with us on the stage? We would like to felicitate you. And may I request Shri Upendra Singh ji, Senior GM Operations, Bikanerwala Foods, to please join us on the stage and kindly felicitate sir for his presentation. Thank you very much, Dr. Mukesh Sonawane, AGM Application Support, IndiFOSS Analytical. Thank you. Thank you so much, sir, for doing the honors, and thank you very much for your presentation.